20 factorial, 21 factorial. Already we did a lot of questions based upon this model. N is 20 factorial into 21 factorial and so on up to 33 factorial power 3 factorial. This is the question. 20 factorial, 21 factorial and so on up to 33 factorial power 3 factorial. Already we did it. 20 factorial till 24 factorial. There are 4 zeros at the end, 5 numbers will be there. 25, it is 5 square, so there will be a jump of 2. It will be 6 into 5. 30 factorial till 33 factorial, there will be one, how many numbers? 30, 31, 32, 33. 4 numbers, 7 into 4. 7 into 4. So answer will be 4 into 5 plus 6 into 5 plus 7 into 4 into 3 factorial. A power m power n will become a power m into n. A power m into n. Is the idea it is clear? From 20 to 24 there are 4 zeros at the end. There are 5 numbers. 25 to 29 there are 6 zeros at the end. There are 5 numbers. 30 to 33 there are 7 zeros and there are 4 numbers at the end. A power m plus n. So this will be 5 power 4 into 5 plus 5 power 6 into 5 into 5 power 7 into 4 power 6. So that is the reason addition came. That is the reason addition came. Next one. If the product has 68 trailing zeros, very, very important concept, sir. Please write down this concept. Key point. Key point. N factorial ends with x zeros. If n factorial ends with x zeros, then n should be greater than 4x. If n factorial ends with x zeros, then n is greater than 4x. I have discussed this proof in highest power concept, but I'll discuss it again. Now, number of trailing zeros. Listen carefully, sir. Number of trailing zeros. Number of trailing zeros for n factorial is given by highest power of 10 in n factorial. 10, it can be further optimized into highest power of 5 in n factorial. 5 in factorial, number of zeros at the end is given by the highest power of 5. Number of zeros at the end is given by the highest power of 5. Are you all with me? We have done so many problems. Suppose 100 factorial ends with dash number of zeros. 100 factorial ends with dash number of zeros. 100 first I divided by 5. 5 20s are 100. 5 4s are 20. 20 plus 4 is 24. Same is the case if I do it vertically. First I divided 100 by 5. Then I divided 100 by 25. Whatever I got, that itself is the answer. 100 by 5 is 20. 100 by 25, it is 4. That means, how to get the number of zeros at the end for factorial? First divided by 5. Then divided by 5 square. Then divided by 5 cube. Keep on dividing it till you cannot further divide. Suppose if n is 75, 75 by 5, 75 by 25, you cannot further divide. If n is 1000, 1000 by 5, 1000 by 25, 1000 by 125, 1000 by 625, these keep on dividing will stop at a point depending on the value of n. These n by 5, n by 5 square. Why? Because for a factorial problems, number of zeros at the end is dependent on the power of 10. Power of 10 is dependent on the power of 5. Why? Because when you are writing 10 natural numbers product, 5 will come in the 5th place and 10th place. 2 will come in 2nd place, 4th place, 6th place, 8th place, 10th place. Power of 2 will be greater than the power of 5. So, these value will be stopping at a point. Can I say that 1 plus 2 plus 3 is always less than 1 plus 2 plus 3 and so on up to infinite? So if I equate this series with an infinite series, this sum finite series is always less than infinite series. N by 5 square, n by 5 cube, and so on up to infinite. So if I take n by 5 common, this will be 1 plus 1 by 5, 1 by 5 square, and so on. So this will be x is less than n by 5 into 4 by 5 by 4. 4x is less than n. N is greater than 4x. Extremely important key point, sir. Very, very important key point. What is the relationship between number of zeros at the end and the factorial? N factorial ends with x zeros. Relationship between n and x is n is greater than 4x. N is greater than 4x. From where we got n greater than 4x? For a factorial, number of zeros at the end is dependent on the power of 5. So divide 100 with 5 and 5 again. So this 4 is dividing by 5 square. Am I right? So depending upon the value of n, this is a finite series. Finite series is always less than infinite. So this will be x is less than n by 5 plus n by 5 square, n by 5 cube, and so on up to infinite. So n will be greater than 4x. Very, very important key point, sir. Please write down. Please write down. Now, let us solve this question. Once you understand this concept, it is just a 1-minute job to solve our question. Let us solve this question. What is the question? If the product 1 into 2 into 3 and so on up to n. 1 into 2 into 3 till n, it is an n factorial. It has 68 trailing zeros. So, what is the concept? N factorial ends with 68 zeros. N factorial ends with 68 zeros. If n factorial ends with x zeros, what is the relation between n and x? N is greater than 4x. 4 into 68. N is greater than 4 8s are 32. So n is greater than 272. N is greater than 272. What is the multiple of 5 just greater than 272? 275. So this will be 5 55s are, 5 11s are, 5 2s are. That means 66, 68. N lowest value. N lowest value which will satisfy this condition will be 275, and n highest value will be 275, 276, 278, 279. Till 279, number of zeros will not change. Very, very easy question. N factorial ends with x zeros. N is greater than 4x. N is greater than 272. What is the multiple of 5? Just greater than 272. 275. Already we discussed from the multiple of 5 till the number which is just before the multiple of 5. Number of zeros will not change. Lowest value will be 275, highest value will be 279. So the maximum value it can take is 279. All these are possible. Highest will be 279. highest will be 279. Very, very important key point. The relationship between a number which is in a factorial format and the number of zeros at the end is given by n is greater than 5x. Y equivalent to became less than, it is a finite series. It's an infinite series. Finite series is always less than infinite. Finite series is always less than infinite. I hope the idea it is clear. Suppose if the question is n factorial ends with 17 zeros. N factorial ends with 17 zeros. What is the maximum value n can take? Another sample question. N factorial ends with 17 zeros. What is the maximum value n can take? N is greater than 4x. That means n is greater than 68. What is the multiple of 5 greater than 68? 70. So 5 14s are 5 2s are. 14 plus 2 is 16. I want 17. Take the next multiple. 5 15s are, 5 3s are. 75 is a multiple of 25. So there will be a jump from 16 with 2. 16 to 18 there will be a jump. How many values n will take? Such that n factorial ends with 17 zeros. What will be the answer? No value x takes. No value x will take which will satisfy this equation. N is greater than 4x. N is greater than 68. We are working with factorial numbers. In factorial numbers, number of zeros at the end is dependent on the power of 5. So check for the multiple of 5. 70, I got 16. Next multiple of 5, 75, I got 18. Why there is a jump from 16 to 18? 75 is 25 into 3. So extra 2 will come. Extra 2 will come. I hope this concept it is clear to you. Next one. 55. 55th question. Already we have done enough number of questions of this model. So this is 3 1s are 3, 6 is 3 2s are, 9 is 3 3s are, 12 is 3 4s are, 360 it is, 3 120s are. So this will become 3 power 120 into 120 factorial. Number of trailing zeros in factorial is dependent on the power of 5. 24 plus 4. Number of trailing zeros will be 28. Number of trailing zeros will be 28. I hope it is clear. 3 power, it's of no use to us. 120 factorial, it is 5. Answer is 28. Next one. Already we did similar question. We already solved it. Similar question already solved. We have done enough questions of this model. 1 into 4 into 7 into 10 into 13. Next one. Find the number of trailing zeros of this number. Trailing zeros is only digit at the hundreds place. Digit at the hundreds place. Now see here. Listen carefully, sir. Units place, tens place, hundreds place. That means third digit from the right. I want third digit from the right. I want third digit from the right for this expression. Third digit from the right. Right? First digit is unit digit. Second digit is tens place. Third digit it is hundreds place. Third digit from the right. Now see here. This can be written as 2 power 80 into 5 square into 3 power 100 into 7 power 93 into 11 power 111. These can be written as 2 power 78 into 3 power 100 into 7 power 93 into 11 power 111 into 2 square into 5 square. 2 square into 5 square. 2 into 5, 10. 10 square last to 2 digits. It will be 0, 0. 10 square last two digits will be 0, 0. That means I need to find the unit digit of this number. I need to find the unit digit of this number. How to find out the unit digit of this number? Use the cyclicity 4. 4 into 19 plus 2. 4 into 25. 4 into 23 plus 1. 1 power any number, it will be 1. So what is the concept for the cyclicity? A power 4k plus 2. It is a square. A power 4k, it is a power 4. A power 4k plus 1, it is a. Already we discussed a good number of sessions related to finding the unit digit of a number. Related to finding the unit digit of a number. So this will be 4. A power 4, 3 power 4, 81 into 7 into 1. Digit at the hundreds place, it is 8. Another very, very good question, sir. 4 power 40 into 5 square into 3 power 100 into 7 power 93 into 11 power 111. 1 power any number, it is 1. 2 square I took it out and 5 square I took it out. 2 square into 5 square is last two digits, it is 0, 0. 78 is 4 into 19 plus 2. A power 4k plus 2, it is a square. So first is 4. 3 power 4 into 25, 1. 4 into 23 plus 1, it is 7. 1 power any number, 1. 4 sevens are 28. Unit digit will be 8. Unit digit will be 8. Please put a star mark on this question. It's a CAT replica question. It's a CAT replica question. Very, very good question. Where the last two digits are becoming 0, 0. Where the last two digits are becoming 0, 0. Next one, 57th over. N factorial is having 32 zeros at the end. How many values n can take? What is the concept? N is greater than 4x. What is x? Number of zeros at the end. So n is greater than 4 into 32. 4 32s are 128. N is greater than 128. Let me take the first multiple of 5. Greater than 128. 130. 5 26 are. 5 5s are. 5 1s are. 26 plus 6 32. So 130 factorial till 134 factorial. Number of trailing zeros will be same. Number of trailing zeros will be same. It is 32. How many values n can take? 130 factorial, 131 factorial, 132 till 134. Answer for this question will be 5. Answer for this question will be 5. N factorial ends with x zeros. N is greater than 4x. N is greater than 128. What is the multiple of 5 greater than 128? 130. 5 26 are, 5 5s are, 5 1s are. So it is coming out to be 32 zeros. So from 130 to 134, total 5 numbers have got 32 trailing zeros. If you know this concept, it is the 10 seconds problem, sir. If you don't know this, then you will find it very difficult. Next one, n factorial has 17 zeros. Already we discussed n is greater than 4x. 4 into 17. So what is the multiple of 5 greater than 68? 5 14s are, 5 2s are, 16. 17 will become 5 15s are, 5 3s are, 16 to 18. So answer is no value, it is possible. Please put a star mark on this question. 59th. Now another variety of questions. Read the question first. Read the question first. Which of the following cannot be the number of trailing zeros at the end of any one of the factorials? Which answer option cannot be the number of trailing zeros? Which answer option? Suppose if I take option 1, If I take option 1, what is option 1? 48. N is greater than 4x. 4 into 48. N is greater than 192. N is greater than 192. What is the multiple of 5 greater than 192? 195. So this will be 5 3s are, 5 9s are, 5 7s are, 5 1s are, 5 1s are. I hope it is clear. So this will be 39 plus 6 plus 1. So this will be 47 zeros will be there. 47 zeros. Next multiple, it will be 5 40s are, 5 8s are, 5 1s are. 40 plus 8 plus 1. 49 zeros are there. Am I getting 48 zeros anywhere? No, it is not possible. 49, it is possible. 47, it is possible. Suppose if I take next multiple, 205, 541s are, 5 8s are, and 5 1s are. 49 plus 1, 50. All these three are possible. First option, it is not possible. First option, it is not possible. I hope the idea, it is clear. Very, very good quality question, sir. Next one. See here. Next question. Which of the following can be the number of trailing zeros? Previous question is cannot be. Now it is can be. First option. First option. Option 1. N is greater than 4x. 4 into 63. N is greater than 252. N is greater than 252. What is the multiple of N greater than 252? 255. 551s are, 510s are, and 52s are. 51 plus 10, 61 plus 2, 63. It is possible. Suppose if I take option 2. Option 2. N is greater than 4x. 4 into 68. So this will be N is greater than 272. What is the multiple of 5 just greater than 272? 275. 5 5s are 25. 5 5s are. It will be 5 11s are. And it is 5 2s are. 66 plus 2. 68. These also possible. Two options are possible. So answer will be all of this. There is no option 1 and 2 or option 2 and 3. If 2 are possible, answer will be all of this. Let us check it out. Option number 3. N is greater than 4x. 4 into 74. So this will be 296. What is the multiple of 5 greater than 296? 5 60s are. 5 12s are, and 5 2s are. 74. It is also possible. Option 4. It is 80. N is greater than 4x. 320. 325. 5 63s are. 5 12s are. 5 2s are. 5 65s are it is. 5 13s are. 5 2s are. 80. Option 1, 2, 3, 4 possible. N factorial ends with x zeros. Then the relationship between n and x is n is greater than